Okay, exercise 14.04, question 12. Now this time we've got squares on the outside of the algebraic fractions, which makes life just a little bit more involved, a little bit more complicated, but nothing too scary. So what we've got to do is we've got to do the squares first before we can multiply the fractions inside the brackets. So of course a square literally means I'm going to square the top number, the numerator, and I'm going to square the bottom number. But a square, or a power outside the brackets, means I can just simply multiply each individual element inside by, the powers by the power outside. Because really this is 10 to the power of 1. This is x to the power of 2. So I could think about this, if you like, as 10 to the power of 1 over x to the power of 2. And now I'm going to multiply each of those elements by that 2. So this is now going to be 2 times 1. So it's going to be 10 to the power of 2. Of course, 10 to the power of 2 is 100. So I'm going to write that down now. So that's going to be 10 to the power of 2. I'm just going to put 100. Now, I'm also going to multiply that 2 by the 2 here. So that 2 and that 2 are also multiplied. So 2 times 2 is 4. So this is going to be x to the 4. Now let's see what we had before. Well, this is going to be multiplying that 2 there. Well, 3 times 2 is 6. So it's going to be x to the power of 6. And of course, this is a 5 to the power of 1. Or I could just say 5 to the power of 1 times 2 is 5 to the power of 2. And of course, 5 to the power of 2 is, of course, 25. So I could just write that down straight away. Or I could just say 5 squared is 25, 10 squared is 100, and life's nice and easy that way. All right, so let's multiply that out. I've got now x to the 6, 25, and let's see what I've got. Now, in this case, I'm going to write a long vinculum and write all this out. I've got 100 times x to the 6, and I've got 25. I'm going to write the 25 over here this time, times x to the 4, because I can simply, you can see the x's here, and I can see the other numbers here, the integers. So 25 goes into 100. Well, it goes in 4 times. So straight away I've got a 4 of some sort. Now I've also got x to the 4, x to the 6, and I could just think about that as x times x times x times x times x. Oops, that's meant to be an x. 1, 2, 3, 4, 5. One more x. That's a very bad x, by the way. I do apologize. You get the idea, though. This is x to the 4, x times x times x times x. And I haven't put times in between, but you can see that these are times. If I just have letters next, so if I had a, b, for example, that would mean a times b. So xx means x times x. So now I can say, well, x divided by x is 1. I could put times 1 if you like. X divided by x is 1. That's another times 1. X divided by x is another times 1, because it goes in 1 times. X goes into x 1 times. So I've got 1 times 1 times 1 times 1, which is still 1, times x leaves me with x times x, which is x squared. So on the top, I'm going to end up with x squared. And we've got rid of everything on the bottom. So the answer is going to be 4x squared. Another way you could consider this is looking at the powers here, knowing that when we divide powers where the base is the same, in other words, they're both x's, if I've got x to the 6 divided by x to the 4, really what I'm doing is I'm saying x to the 6 minus 4. I'm subtracting the powers. And of course, 6 minus 4 is 2, which means it's x to the power of 2, which is indeed what we see over here. And there is my solution.